So you are using an older card that is coming to an age where the performance may not be as great as it used to be. So this video might be for you because we are going to show you how to overclock this card. And this is not only supposed to be showing it for older generations, but is also relevant for the RTX 20, 30 or even 40 series. Because overclocking graphics cards has not changed much in the last few years. We are going to show you this as an example on a RTX 4090, which is known to be a very power-hungry card, and yeah, enjoy. Generally, for overclocking, I would recommend tools like MSI Afterburner, EVGA Precision, or A-Series GPU Tweak, for example. Also, depending on what your preference is, the only thing that's really different is the user interface, and so there is not much to choose from in terms of features or whatever. I just like to use MSI Afterburner because it is relatively straightforward if you use the legacy designs, and it also has a nice on-screen display with the Riva Tuner statistics server, so we can monitor everything in-game. For testing purposes, I'm going to use two different scenarios. One is a game where I know that high clock speeds are relatively unstable, which is in my case Ratchet & Clank Rift Apart. I have seen a few cards crashing with lower clock speeds than on different games, although that game does not use as much power as, for example, Times by Extreme Benchmark, which squeezes the RTX 4090 pretty hard and hits the maximum power limit as well. Ratchet & Clank does not, but the good thing is then that you reach the maximum clock speeds, so this is a good test to check if the card is stable. But generally speaking, even if the card is stable in that game, I would recommend running other titles later to check if everything is stable. So not just this one game, but your whole library and the games that you are playing, so that you're not experiencing sudden crashes or whatever, which is, well, not fun. Going into the process of overclocking, it's relatively easy. We are going to start looking at the stock frequency that are being hit with that card. As I said, it is not really about the power limit in the case of the Ratchet & Clank test that we are doing here, or in the game test, but more about the clock speeds and what exactly is stable. We see that this card is relatively heavily voltage limited, so that the GPU needs more core voltage to hit higher clock speeds. That's also something you can tell from GPU Z or from the limits that it's hitting. It will say VREL, for example, or if you are hitting temperature limits, it will say temperature, or it will say power if you're hitting the power limit, for example. So that's something you can look at as well, and then therefore increase those limits accordingly. We are just going to increase the voltage limit to the maximum. In the case of the RTX 4090, we are increasing the GPU core voltage only to a set maximum that it can go to, so we're not increasing it by 100 millivolts, although MSI Afterburner says it. We are just increasing it by a maximum value, which in this case is 1.1 volts. And there you can see already the GPU frequency jumps up quite a bit, so there's already a big gain in there. The issue there is, though, because we are also changing the voltage, the power consumption goes up quite a bit. And this is the case on any graphics card. When you increase the voltage, the power consumption will jump up. If you only increase the core frequency, for example, the power consumption does not go up that much because you are not increasing the voltage, as I said, because the maximum voltage is already set, and if you're not hitting the power target, the maximum voltage of, in this case, 1.05 volts is hit. Therefore, the voltage is not changing, and raising only the clock speed will not result in a lot of power increase or power draw increase. Going from there, we will test how much we can raise the GPU clock speed. Or rather, we will first put the power limit at the maximum also, it is not really relevant for this test, but for further tests in 3D Mark TimeSpy, for example, we just want to do that anyway. So we will go from there and then, as I said, continue with the GPU clock speed. In this case, we will just up the clock speed in 25 megahertz steps. So just go plus 25 megahertz, then go into the game, test for like a few, like 20-30 seconds. And if it's stable or if it's running without any issues, without any graphical glitches, graphical errors, any whatever streaks or any artifacts, then you can again raise it 25 megahertz and so on and so forth. In our case, we experienced a crash at 150 megahertz. So we dialed it back 2 steps from there to 100 megahertz plus. You can also obviously do it in tighter steps, so you could dial it back only 25 megahertz and see if that is stable, if you want to get a bit more risky. But we did 2 steps and we tested for a longer period of time if 25 or if those 100 megahertz are stable. The next thing we did is we tested the memory clock, because there's also a lot of performance to be had increasing this, and there's also not a lot of power consumption that is going to go up. The only problem is with memory, I would recommend if you have a card that has memory on the backside, so you can look that up if you look at some PCB photos or whatever, and that it has cooled memory, because if memory temperatures go above a certain temperature for long periods of time, it can hurt the memory, and therefore memory overclocking might be something that you should be careful of. Here we are going for 50 megahertz steps, although in hindsight I would have recommended going for 100 megahertz steps, because the RTX 4090 apparently overclocks very well in terms of memory. So we've reached 2 gigahertz plus on the memory, so we've maxed out the slider on MS Afterburner. Obviously we could have used a different tool where maybe the slider allows more overclocking on the memory, but I think 2000 megahertz still is pretty good. Also, memory is kind of difficult because some tools differ in the clock speed that they show on the memory slider. So they may show only the double data rate or the single data rate of the memory. You obviously have to look out for that, and just test accordingly and what is stable, so that you can find out what the limits are. Also, I would recommend, if you have overclocked the GPU, set that back to 0 and then test the RAM, because it can happen that the GPU frequency, a higher GPU frequency, influences the memory frequency, and you cannot go as far with the memory clock if the GPU is overclocked as well. So just overclock both of them separately, and then in another test check if they both run together at that speed you determine to be stable, just to be on the safe side, so that maybe it's not the case that you overclock the GPU 15 megahertz further and the memory, because of that, does only do 1000 instead of 2000 megahertz. We have had that happen lots of times, so just that you are aware of this, and just so you know, that could be an issue. Last thing we will do is look at the power limit. The stock RTX 4090, our Tough Gaming also has that, does have a power limit of 450 watts stock, and we can raise it up to 600 watts. In 3D Mark TimeSpy, we are hitting those 450 watts pretty often, especially in test 2. And because of that, we are going to raise that. Obviously, you can save a bit of power if you don't raise it to the maximum. If you, for example, don't want to run your GPU at 600 watts, that's obviously a possibility. And most games on the 4090 or on many newer cards will not hit the power limit, the maximum power limit. And then you can limit it to like 450 watts or go even lower. But you gotta keep in mind that you might lose some performance. So, okay, you can see that we were able to increase the frequency by about 200 megahertz plus or minus. Also depends on the game, on the title, or on the application, which may lead to a performance increase of about I'd say 5 to maybe 7%, also dependent on what you are looking at. And yeah, obviously this is not the same as it was like 10 years ago, where you were able to overclock a GPU to 50% more frequency and get like 30-40% more performance. Nowadays there's not much performance gain to be had as there used to be, but still it is something, especially if you're running at like 35 to 40 FPS. Going 10% above that, for example, you would be running at like 38 to 43 FPS or whatever, if we were looking at like an 8% to 10% improvement, depending on how well your card overclocks. So that makes the experience going, even if it's just a few frames on those lower frame rates, quite a bit better. Obviously, not every card overclocks the same. So even if you have the same RTX 4090 as we do, you are not expected to get the same frequency out of this card as we did. You may get lucky and get above 3 GHz if you are, well, lucky and get a really good card. But it may also go the other way around. So you might also get a card that does not even do 2900 megahertz. This is always, it's called the silicon lottery, and it's always kind of a luck of the draw what card you get and how well it performs while overclocking. So don't expect anything that you are being shown in any videos or whatever. So you just have to test the card for your own. You also cannot just copy any settings from me or from anyone else. They might work, but they aren't guaranteed to. And you might also even be able to get much more out of the card. So it is worth trying it yourself. Anyway, let me know in the comments what you think about this, or how are you experiencing? How are you? I am under the water. How are your experiences with overclocking modern GPUs? Have you had any very good overclocking cards? And yeah, otherwise I wish you a nice day and goodbye.